come across WEP, you should not like it because WEP is not that secure. Okay, so you should like what? WPA. So look for your wireless connection LAN, all these parameter values in your laptop. You can go home and find out what is being used. It should be WPA. If it's WEP, it's not a very strong encryption security mechanism. Okay? So you should use WPA. And the latest version of WPA is WPA2. Okay? Alright? So we'll briefly see what this WPA is. You can get an idea of how it prevents or removes those weaknesses. So one weakness of this thing is it still uses RC4, but remember in WEP, the RC4 algorithm takes this 24-bit initialization vector, right? So, and I said this is generated in random and sent along with the message as a plain text. So you want to avoid that. So in order to avoid that, first of all, you don't use very small key length. So you have to use at least 256 bits as your key length. And the recommended range is 8 to 63 characters. You know, each user has to have a password that is of at least 8 is very small. They recommend 20 characters. Okay, because each character is 8 bits, so it's 160 bits. But the longer you have, the more secure it is. Okay, you can accept up to 63 characters as your password. And then, so if say let someone enter 63 characters as their password. Okay, what it does is it computes a hash value of those 63 characters. 63 times 8 is 504 bits. So it computes a hash value of those 504 bits. So whatever the user entered password, a hash value of it is of length in 256 bits. Okay? So if a user entered less than 8 characters, it won't probably accept. So whatever the user entered password, a hash value of it is computed. That is this 256-bit password being used for everything else. Okay? So that's the first step. The hash value of user entered password is computed. And then there is a kind of a key derivation function. I told you before what a key derivation function does. It's a kind of like a random number generator for which the seed value, random number generators would take seed values, right? And the seed value for the key derivation function is the 256-bit password. Okay, the hash value. The 256-bit hash value is the seed for your key derivation function, and that will generate two things. One thing is your 128-bit temporal key that is used for encryption, and 64-bit key that is used for hashing. So the hashing we use here is not CRC anymore. It's a kind of keyed hashing algorithm. Keyed hashing means along with the message you have to also pass the 64-bit key for that for the hashing algorithm. Okay? Now, since the password entered by the user is also known as the access point, so both the wireless device and the access point should be able to compute the same 256-bit hash value. Okay, because they use the same password, they should be able to arrive at the same 256-bit hash value. So the power is, all this 128-bit key to be used for encryption is arrived at locally by the wireless device. Same way the access point will also be able to come up with this 128-bit key. Okay, so you may wonder how they get to know, because the same password is kind of, the user password is also known the access point. Okay. Now, instead of using the 24-bit initialization vector as a randomly generated value, the way this, you operate RC4 here is you still use RC4, but instead of generating a 24-bit initialization vector, it generates actually a 48-bit initialization vector, which is more powerful. And this is basically a sequence number. So it could be like incremented by 1. So you start with all 48-bit zeros and then increment by 1 and then 2 and so on. But I said this is what is called a temporal key. What do you mean by temporal? You know from English what is temporal means? Anything to do with time. So from the time you start a session, a particular 128-bit key will be generated and will be used for a while for a fixed time period, and then a new 128-bit key is generated. So you don't use the same key for all your encryption. Okay? So first you start the user password and get a 256 hash value for bit hash value, and then using the key derivation function generate your first 128-bit temporal key and encrypt some messages using that key, and then after a while just use a different key, and the same sequence of 128-bit temporal key will be used at both sides again, because why? They use the same key derivation function. So you know from a random number generator, if you use the same seed value, the sequence of random numbers that you generate is the same, right? So have you ever tried that in the random number generator? So since both the wireless device and access point use the same key derivation function and the 256-bit hash value, they'll be able to generate the same sequence of 128-bit temporal keys. So this 48-bit initialization vector is like a sequence number that is sent, that is incremented every time you want to send a message. So you don't need to send a randomly generated 24-bit initialization vector in plain text anymore, because it's a sequence number, nothing more than that. And it's a temporal key, so both sides should know when to change from one key to another key. And same thing with the hashing. So you could generate a 64-bit key for a while, and then after a while you change to a different 64-bit key and do the hashing. Okay? And it's a keyed hashing again. So with that you can also make sure the message is coming from that particular sender. Okay? And so this way, this is how it works to be more like, again, it still uses the RC4, it doesn't use any powerful encryption algorithm, but it increases the bit size. It requires users to have up to from 8 to 63, and it produces a hash value of the user entered password, which is 256-bit long. And this is the basis for everything else. So this is used as a seed for your key derivation function to generate a 128-bit temporal key. By temporal I mean it changes with time. So for a fixed time you use one particular 128-bit key, and like you generate a sequence of random numbers. So after a while you generate another 128-bit key, and so on. So the same sequence of 128-bit keys will be used at both sides by the client as well as the access point. So there's no need to send anything on the channel for the other side to know. And the initialization vector used is not randomly generated. It's basically a sequence number starting with 0 and then 1 and so on. And once the 128-bit temporal key is changed, the sequence number is changed back to 0. So for a particular 128-bit key, you have a sequence number incremented from 0 all the way to higher value. And then once you change your temporal key, the sequence number is reverted back to 0 again. Okay, so the same protocol is followed at both sides. So there's no need to send this sequence number in plain text on the channel for someone to look at what it is. Okay, so this way, with all these features, this is more secure than the WEP standard. Okay, so this is what is WBA, Wi-Fi protected access. Okay, so so we'll continue with this, the rest of this. The second step, now what you see in next class is mobile phone security, back gap problem, and all the things very complete next class. So let me give your this in exams so far.